Anybody asking about the power rule for trig? Today's your day. Here's the derivatives of our trig functions. Yes, you need to know them. I would focus in on the first three. The last three are not as important, but they are still important. We will talk later on about how we could come up with those and derive those a little easier. The first three definitely you got to know. Secant of x we use quite a bit. Cotangent, cosecant, not so much, but we will use them here and there. So running through those, the derivative, the d dx tells us derivative of the sine of x is the cosine of x. The derivative of cosine of x is negative sine of x. The derivative of tangent of x is secant squared of x. Derivative of cotangent of x is negative cosecant squared of x. Derivative of secant of x is secant tangent, and cosecant's derivative is negative cosecant negative cosecant x cotangent x. So there are a couple of things that you can look at and say, oh yes, especially if it's a multiple choice question. One, if our trig function starts with a c, if it starts with a c and we're taking the derivative of it, we're going to end with a negative value. Negative value. Our secant and cosecant is the only ones with two terms. And secant has secant in it, cosecant has cosecant in it. Tangent and cotangent are the only ones with a squared in them. Tangent of x goes to secant, cotangent goes to cosecant. So our c's go together with that one if you want. That's not as easily remembered, more than knowing that tangent and cotangent are both squared, secant and cosecant both have two terms in them. Basically, it's a memorization thing. Got to remember them, especially the first three, as well as secant is used quite a bit. So how are we going to use this? Well, we're going to find the derivative again today. Again, all power rules, so we're going to find the derivative of 2x. It's going to be 4x. Derivative of negative 5x is negative 5. Derivative of cosine is negative sine, so we're taking the minus the negative sine of x. So some of you are going to realize that this is a plus sign when you go to do it. Just be careful that you don't lose that negative sign. Cleaning it up, we'll never see minus a negative, we'll see it as a plus the sine of x. And there's our answer. In example 2, we're looking for the derivative. We have 1 over x to the square root of x, which is x to the 1/2 on the bottom. So we're going to bring this to the top as a negative exponent, change it to a fractional exponent as well as we're doing it. So the derivative is going to be negative 1/2 x to the negative 3/2. The derivative of cotangent, remember it starts with a c, so it's going to be a negative. Cotangent is one of the squareds. Oh, I got to think about that. Oh yes, cosecant squared of x. And there's our answer. Just a couple more examples and we'll be done. It's not going to be a big day today, just remembering those rules. So e cosine of x. Notice we talked about e's yesterday or a couple days ago. Here, we don't have e to the x. We just have e. Remember, e is a number, 2.71828, blah, 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 blah. So this is just a number times the cosine of x. So the derivative, that e is going to stay e, and then derivative of cosine of x is negative sine of x. When we go to put a variable on the top of this, it becomes a whole nother ball game and a whole nother problem. So be careful with that. If it's just a number in the form of a number, it acts like a number. If it's e to an exponent, then it's an exponential function, completely different problem. So again, we can clean this up as negative e to the sine, or negative e times the sine of x. And that's our derivative. Example 4, the last one I'm going to give for you today. Find the equation of the tangent line if the graph is f of x equals 3 minus the cosine of x when x equals 0. Again, equation of the tangent line. Hopefully you see the theme. We're doing a lot of equations of tangent lines. So the first thing we're going to do is find f prime of x. Our derivative of 3 is 0. Derivative of negative cosine of x is positive sine of x. We know that x is going to be 0. So we're finding f prime of 0. So we're looking for the sine of 0. The sine of 0, hopefully, we go back to that unit circle if you need to. Here's our 0 value. We're looking for the cosine sine. That point is 1, 0, so the sine is 0. So f prime of 0, or the sine of 0, is 0 as well. That's our slope. We can also plug in to find our y value. So we're finding f of 0. That's 3 minus the cosine of 0. Again, going back to the unit circle, remember we have cosine sine. That point when x is 0 or theta is 0 is 1 for the cosine. So the cosine of 0 is 1. So 3 minus 1 gives us 2. That is our y value. So we have the point 0, 2, and we have a slope of 0. So my equation is y minus 2 equals 0 times x blah, 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 blah. Doesn't matter because it's being multiplied to 0. We can clean this up, maybe make it look like y equals 2. And that's going to end our equations, or derivatives, with trig. I'm going to throw this back up there again, just a recap. So you have it and you can write those down. Make sure you've got them down in your notes. Good luck and enjoy the trig.